Lesson 25B, we're going to return to the idea of solving word problems using proportions, but we're going to talk about it a little bit more in depth. And we want to make sure that our answers make sense, so we're going to do some checking. Okay, so we're going to use proportions to solve word problems. We're going to explain, using our words, what the given rates are. And why are we learning this? Because in real life you might want to find out how much sugar you need to make cookies, keeping those recipes proportional. If you want to make more or less. Anyone need more time writing this down? Okay. Alright, so number 1 on your notes, we have a word problem that reads, a loading crew estimates that it can load 6 boxes every 5 minutes. At that rate, how many boxes can they load in 28 minutes? So I want you to write down the proportion you think you can use to solve this problem. Write down just a proportion. I'll give you about 30 seconds. Okay, I see that most of you did it the way I taught you, which is good. But if you're given a rate and you're asked to find another rate, you can use a proportion to solve the problem. So this first part, 6 boxes every 5 minutes, this is a rate. It's a comparison of 2 different things, right? Boxes and minutes are different. So that is a rate. Does it ask us to find a rate? It says at that rate, how many boxes can they load in 28 minutes? Are they asking us to find a rate? Yes, they are. We need to figure out how many boxes per 28 minutes. So we can use a proportion to solve this problem, and the given rate is the yellow one that I highlighted. And most of you did write boxes on top, which is good. I just labeled it just to make sure my other ratio is also boxes on top. If you wrote minutes on top, it's fine as long as your other ratio also has minutes on top. Okay? So there are a few ways that would be correct to write this. We can have boxes on top or minutes on top. So you can write it like this, which most of you did. If you flip the entire thing upside down and had minutes on top, it would look like this. This is still correct. Or if you wrote the x over 28 first, that is still correct. Or if you wrote the minutes on top and the 28 over x first, that is also correct. These are all the same proportion. Some incorrect proportions would be if you twisted it. If you had boxes on top for the first ratio and the minutes on top on the second ratio, this is no longer proportional. You twisted it up. Minutes does not equal boxes. It has to be boxes equals boxes, minutes equals minutes. Okay, so these are all the twisted up ones. You cannot set it up like that. Most of you set it up this first way. So let's just talk about it this first way here. So 6 over 5 equals x over 28. I need to read it towards the variable, right? Going this way. So what number do I start with when I want to show my work? Yeah. Which number do I start with when I write my work? The 5. Good. So with the 5, I'm going to write times my multiplier, which is 28 over 5, because the goal is to cross-cancel those 5s, right? Then I use the same multiplier to the top part. 6 times multiplier equals x. So 6 times 28 over 5 equals 168 over 5, which then simplifies to 33 3/5. So x equals 33 3/5 boxes. Go ahead and write this down. So it's the same process we've been practicing all week, right? But the only thing new today that I want you to focus on is looking at this answer you got and seeing if it makes sense. So does this answer make sense? We can use equivalent fractions, which are ratios, and scale up to see if it makes sense. So if you have boxes over minutes, which we started with 6 over 5, right? Times 2 would be 12 over 10. 6 over 5 times 3 would be 18 over 15. Times 4, then times 5, then times 6. And this is right where we want to be looking at. Between 25 and 30 is the 28 minutes, right? We want to find the rate for 28 minutes, which is between the 25 and the 30. Now, the question is, does our answer fit in between these numbers? Is it between 30 and 35? Yes, so that means our answer makes sense. If we got something like x equals 7, it should be between these numbers, but would 7 be between those numbers? No, that means you did something wrong and your answer doesn't make sense. Does that make sense? So we always want to mentally check our work to make sure your answer even makes sense. If it totally doesn't make sense, then you probably did something wrong. Okay? So again, if you are given a rate and it asks you to find a rate, then it's okay to use a proportion to solve that problem. So here are some words or phrases that are commonly found in rate problems. For every, for each, and per. Go ahead and write that down. It's in the box on your notes. And we've worked with these terms before. Means the same thing. So looking back at number 1 here, do you see any of those words in the word problem? Yes or no? Yeah, which one? It's yellow. Every. Good. Every or for every, that means the same thing. So 6 boxes for every 5 minutes or 6 boxes per 5 minutes. This means the same thing. And that means that you can use a proportion to solve this problem. Okay? So let's look at number 2. If it takes 6 cups of flour to make 54 cookies, how many cookies can be made with 10 cups? Does it give us a rate? What is it? Good. 6 cups of flour to make 54 cookies. Does it ask us to find another rate? Yes, it asks us to find how many cookies with 10 cups. So that means we can use a proportion to set up and solve this problem. So I'm going to set this up with you. 6 cups of flour for every 54 cookies is our given rate. So I'm going to write that as a ratio, 6 over 54. And since I wrote 6 cups on the top, my other ratio in the proportion also needs to have cups on top. So I'm going to write 6 over 54 equals, what do you think? Good, 10 is on top. 10 over x. X being the number of cookies. Go ahead and take about 2 minutes to solve this proportion. Alright, so we should have a multiplier of 10 over 6 because we want to cross-cancel the 6's to equal 10. And then I want you to start reducing your multipliers. I know that looks tiny, but it says 5 over 3. And this is important because our lesson tomorrow, you're going to need to start reducing those multipliers. So let's just start that today. Find your multiplier and then reduce it. Plus, smaller numbers are easier to work with anyway. So 10 over 6, which is 5 over 3. So my multiplier is 5 over 3. I'm going to use that with my 54. 54 times 5 over 3 equals my x. And what did you get for x? Good. 270 divided by 3 would be 90 cookies. Okay, so we got 90 cookies. We want to make sure that this makes sense. So let's do the scaling again. We started with 6 cups of flour for 54 cookies. I'm going to multiply that times 2 and get 12 over 108. And then my 10 cups fits between there already, so I can stop my scaling. 10 cups is between 6 and 12, so my 90 cookies has to be between 54 and 108. Is it in between? So my answer makes sense. Okay? If you got, let's say, 30 cookies, you'll see that you either did your math wrong or your proportion was set up incorrectly. Something went wrong. Okay? Make sure your answer makes sense. Go ahead and try number 3 all on your own. All right, let's talk about number 3. We need to set up a proportion to solve this problem because they give us a rate. And what is that given rate? Thank you. 91 books in 7 hours. That's the given rate. So that's the first part of your proportion. What is the rate they're asking us for? How many books in 12 hours? So if I have books on top, what do I have to have on top in my other ratio? Also books. Is that going to be X or 12?
X.
X. Good. We don't know how many books. It says how many books. So that would be X. So your proportion setup should look like 91 over 7 equals X over 12. If you don't have that, please fix it. If you twisted it, I saw a few of you twisted it up.
Are you going to use number 91 equals 12 over X?
Yes. You'll get the same answer. Alright, so I need to read this towards the variable. So I'm going to start with 7. 7 times my multiplier equals 12. What would that be?
12 over 7.
Good, the goal is to cross the 7 out. So my multiplier will be 12 over 7. So now I need to write my other problem, which is this one. 91 over 1 times 12 over 7 equals X. Yes. This gives me 1092 over 7, which is how many books?
156 books.
Good. Does 12 over 7 reduce? Nope, so that's just my simplified multiplier, 156 books. And does your answer make sense? Yes, this one does make sense. Very good. Let's look at number 4. A recipe for 20 rolls calls for 5 tablespoons of butter. Is that a given rate? Is it a comparison of 2 different things? Yeah. Yeah, so that's my given rate. How many tablespoons are needed for 35 rolls? Do they ask me to find a different rate? Yes, they're asking how many tablespoons for 35 rolls. Those are still 2 different things and one of the things I don't know. So I'm going to find another rate, which means I can use a proportion to solve this problem. Given rate was 20 rolls for 5 tablespoons of butter, or you can have 5 tablespoons per 20 rolls. I'm going to have the tablespoons on top this time. How many tablespoons? That would be X for 35 rolls. So I'm going to set my proportion up like this, using T for tablespoons. And again, reading this towards the variable means I'm going to start with my 20. 20 times what equals 35? What would that be?
7 over 4.
35 over 20, which reduces to 7 over 4. Good. So I'm going to go ahead and use the 7 over 4 just to make my life easier with smaller numbers. So 5 times 7 over 4 equals my T. What does T equal?
35.
Which is what? 8 3/4. Very nice. Okay, so multiplier was 35 over 20, which reduces to 7/4. So with my top part of the problem that I'm solving, I'm going to go ahead and use the 7/4 to make my life easier, which is 35 over 4, which reduces to, or simplifies to 8 3/4 tablespoons. Does this answer make sense? Yes, it does. Let's look at number 5. Go ahead and try this one. Let's read this. It says, if John is 9 and Rhonda is 5, how old will Rhonda be when John is 18? Does this give us a rate? John is 9 and Rhonda is 5. That's a rate? Is it comparing two different things? No. They're saying age and age. That's not a rate. Those are not two different things. So already I can't use a proportion to solve this problem because they didn't give me a rate. But let's just go ahead and try this. Okay, what's a rate again? It's a comparison of two different things. So that would be like boxes per minute, or tablespoons of butter per cookie, or hours per miles per hour. Those are two different things, right? Age per age, that's not a comparison of two different things. So let's just pretend that you went on autopilot and set a proportion anyway to solve this. You would probably have done 9 over 5 equals 18 over x, right? John equals John, and then Rhonda equals Rhonda. And then you would get x equals 10. We want to know if this answer makes sense. And it doesn't, because you have to have a rate to solve a rate. That does not make sense. You would have to solve it like this. John is currently 9 years old, and Rhonda is currently 5 years old. In the future, John is 18. That means 9 years later, he becomes 18, right? 9 years later, how old will Rhonda be? 14. So this answer of x equals 10 makes no sense. We cannot use a proportion to solve this because the first part's not a rate. It doesn't ask us to solve for a rate. It's more of a chronological problem. Okay? So just because your word problem has 3 numbers in it doesn't automatically mean you can use a proportion to solve it. You have to read it and see that it gave me a rate and it's asking me to solve for a different rate. That's a proportion problem. Number 6. If it takes 3 people 7 hours to paint a fence, how long will it take 6 people to paint a fence of the same size? Do they give us a rate? 3 people compared to 7 hours. Okay. Yeah, that's 2 different things. Do they ask us to find a rate?
Yes.
Yeah, they do. How long? So that's number of hours for 6 people. So they ask us to find a rate. Or it sounds like they do. Right? It sounds like you can use a proportion, but now let's think about it a little bit more in depth. You would set up your proportion like this probably, right? And then you would solve it and you get x equals 14, which I heard somebody say x equals 14. However, does it answer make sense? It doesn't, because think about this. If it takes 3 people 7 hours to paint the fence, and now you have double amount of people, you now have 6 people painting the same fence, is it going to take longer or less time? Less time. So it's not going to take 14 hours with 6 people, unless you have some like really slacking off workers that are like backwards painting, you have to redo it again or something, right? It should be faster with more people. So this answer again does not make sense. So again, just because there's 3 numbers doesn't mean you can use a proportion to solve it. This particular problem, you need to come up with some other mathematical way to solve this. Okay? So this one is not a proportion problem. So just a reminder, for word problems, you need to look for the words or the phrases or statements that we've practiced that are commonly found in rate problems, which is for every, for each, or per. But even so, you should still think about, does it make sense? Okay? Go ahead and write those words down again in your notes. And it doesn't have to be these words. It just has to make sense. You also have to ask yourself, is a word problem asking for a rate, and they give you a rate, and ask yourself if your answer makes sense. Okay? All right, number ones. Go ahead and share what you learned today while I pass your homework out. Ready? Share.